Now we move on to the introduction part. So under introduction part, first of all, I'm going to touch on the research background. So what is oil spills and its environmental effect? So according to NASA 2023, an oil spill is the release of liquid petroleum hydrocarbon into the environment, especially marine area, due to human activities. Also, according to NASA 2023, oil spills may be caused by the releases of crude oil from tankers, offshore platforms, drilling rigs, or wells. So in figure 1.0 here shows you how oil slicks looks like on the surface of water, which is due to oil spill. So the question is, how do oil spills affect the environment? So firstly, oil spills can cause habitat destruction where oil spills can cut and smooth the habitat such as wetland, beaches, and mangrove, leading to the destruction of these critical ecosystems. Next, oil spills can also cause toxicity, which can threaten the marine's life. Not just that, oil spills can also cause water contamination. And last but not least, oil spills can bring impacts on wildlife, especially the marine mammals, birds, fish, and shellfish. Beside the environmental impact, oil spills can also give impacts to the local economies and recreations. So how does it impact the local economies and recreations? So firstly, it will give impacts to the fisheries and aquaculture sectors where oil spills can harm fish and shellfish populations, which will result into the fishing industries and seafood businesses being disrupted. Next, it will also affect the tourism sectors where oil-covered beaches and waterway deter tourists, which will reduce the revenues for hotels, restaurants, and recreational businesses. Last but not least, it will also affect the recreational activities as oil spills disrupt swimmings, boating, and wildlife watching, affecting businesses that rely on tourism and outdoor activities. So here are some of the example of notable oil spills incidents that are famous and well known by most of us that has occurred during the past. So firstly is the Lakeview well, which is occurring during the year 1910 in California, USA, where the oil spills are estimated to be 378 million gallons. Next is the Gulf War incidents and the Deepwater Horizon incidents, which occurred during the year 1991 and year 2010, respectively. The Gulf War incidents was occurred at the Persian Gulf in Kuwait, with the oil spills estimated around 240 million gallons, whereby for the Deepwater Horizon incidents, it occurred in the Gulf of Mexico with oil spill estimated around 210 million gallons.
Before addressing the problem statement of this project, it's important to understand the current oil spill cleanup methods, which are containment booms and skimmers, dispersants, solvents, and bioremediations. While these methods have their benefits, they also come with significant limitations. Containment booms and skimmers, for instance, are highly dependent on weather conditions and are often ineffective in rough seas or strong currents. Skimmers can also struggle with certain types of oils, especially those that are viscous or mixed with debris, making complete oil removal challenging and leaving residual oil behind. Dispersants has their own drawbacks, including environmental impacts and limitations in effectiveness. They can harm marine life and increase toxicity in the water. Additionally, heavy or emulsified oils do not disperse well. Well, the dispersed oil can become invisible, complicating cleanup efforts. Solvents are another option, but come with capacity limitations, disposal challenges, and labor-intensive deployments. They need frequent replacements as they saturate quickly. The need into hazardous waste that incurs disposal costs. Large-scale spills require substantial labors for deployments and collections. Bioremediation, though promising, is a slow process that can take weeks or months to show the significant results. Its effectiveness is highly dependent on environmental conditions like temperature, oxygen level, pH, and nutrient availability. Some oils, especially those with complex hydrocarbons, resist microbial degradations, limiting the suitability of bioremediations for certain spills. As mentioned previously, we know that oil spills continue to be a devastating environmental threat, causing ecological and economic damage across the globe. Current cleanup methods are often limited in effectiveness, facing challenges in collecting oil efficiently, particularly in rough sea or remote locations. Additionally, some methods can be harmful to sensitive ecosystems. This project proposed the design of a novel device or model that utilizes the innovations to address these shortcomings. It aims to create a solutions that offer superior oil spill containment and recovery while minimizing the environmental impact. By tackling these critical problems with a fresh approach, we hope to contribute significantly to a cleaner and more resilient futures for our oceans and coastlines.
Next, moving on to the importance of the project. So the project plays a crucial role in ensuring effective and cost-efficient cleanup of oil spills, safeguarding clean waters, and also marine lives. Additionally, it aims to raise awareness about the impact of marine pollution on both marine lives and also human well-being. So apart from that, the project is also in line with the SDG 17, which are introduced by the United Nations. There are 17 goals in total, and among the goals, the one that are related to the project are goal number 6, which is clean water and sanitation, that emphasize to ensure availability and sustainable management of water and sanitation for all. Next is goal number 7, which is affordable and clean energy, that emphasize to ensure access to affordable, reliable, sustainable, and modern energy for all. And the last goal is goal number 14, which is life below water, that emphasize to conserve and sustainably use the oceans, seas, and marine resource for sustainable development. Next is the purpose of this project. So the aim of this project is to clean up oil spill on the water surface and to achieve the SDG 17. So what is the objective to achieve the goal? So the first objective is to clean up the oil spillage by using the non-pathogenic microbes. And the second objective is to develop an innovative oil spill cleaning system that is cost efficient, practical, and environmentally safe by creating a prototypes. From the project, we hypothesized that the oil-eating bacteria, which is the Alcanivorax borkumensis, can effectively clean up the oil spillage without harming the underwater ecosystem and also the marine lives.
Let's move on to the literature review. Global water pollution is a crisis affecting every continent, poses a severe threat to human health, aquatic ecosystem, and the sustainability of our planet's most vital resource. At the moment, it is estimated that 44% of the wastewater generated globally is being discharged without undergoing any sort of treatment, while industrial effluent discharge, agricultural drain-off, plastic, oil and oil product, and sewage effluents are the examples of the pollutants. Pollution can be categorized into several types. The first type is the plastic pollution. The plastic that discharged into the ocean can break down into microplastic, later being consumed by the marine life and causing their illness and death. The second one is the chemical pollution. Chemicals like pesticides and heavy metals that enter the water will return back to the food chain and cause health problem in human. Moving on to the nutrient pollution, it is caused by the release of nutrient polluted water from agricultural field, which contribute to the algae bloom that cause oxygen lacking in marine life. The last one is oil pollution, which is also the main focus of our project. Oil pollution can be caused by accidents involving tanker, bunkers, pipelines, refineries, drilling rigs, and the storage facility that cause oil spill into the ocean. There are many negative impacts brought by the oil spill. Oil will reduce the light penetration, inhibit photosynthesis activity in marine flora. It can cause mortality of marine life due to smothering, toxicity, and ingestion of oil. Damage in coral reef, mangrove, human health problems, contamination of coastal vegetation and soil, hypothermia in avian and marine mammal due to oil penetration are also the negative impact of oil spill.
Marine environments face significant ecological and economic harm from oil spills. Understanding their trends and frequency is vital for developing effective prevention and response strategies, especially in those regions that are prone to such incidents. Based on recent data shows that both progress and challenging in managing oil spills. The 2023 statistic from International Tanker Owner Pollution Federation reports that 10 oil spill over 7 tons, a notable decrease from previous years. The average number of ships spilling cargo per decade has halved, averaging 6.8 spills per annum by 2021, consistent with 21st century trends. Oil spill can be categorized as large size if contain over 700 tons of oil and medium size ranging from 7 to 700 tons. In 2023, Asia experienced one large spill of heavy fuel oil and 9 medium-sized spill, including very low sulfur fuel oil, crude oil, and also benzene. These incidents affected the coastlines in Europe with two incidents in Africa, one from America, and 4 incidents happened in Asia. Historically, marine and coastal environment have suffered greatly from major oil spill. Notable incidents included the Torrey Canyon disaster in 1967 with 119,000 tons of crude oil, Amoco Cadiz in 1978 with 223,000 tons, Atlantic Empress in 1979 with 287 tons, Exotic Mexico in 1980 with 454,000 tons, and Exxon Valdez in 1989 with 37,000 tons. In response to this disaster, global regulation like MARPOL 7378 and the Oil Pollution Act of 1919 were enacted to control the oil spillage. So these measures have significantly reduced the large-scale oil spills from an annual average of 24.5 in the 1970 to 1.8 by 2010, alongside increased environmental awareness. Oil spill often stem from various origins, including tanker accident resulting from collision and hull damage, as well as leaks from corroded pipeline and runoff from land-based sources. For instance, the Torrey Canyon tanker disasters in 1967 illustrate a tanker accident caused by a collision, which resulted in releasing of 119,000 tons of crude oil. Similarly, the Sanchi oil tanker spill in China inflicted significant human and environmental harm as its discharge 111,300 tons of natural gas condensate and 1,000 tons of marine fuel. Besides, hull damage has played a significant role in past tanker accidents. One such incident occurred in 2002 with the sinking of the Prestige, which was carried around 77,000 tons of heavy oil. Due to stormy weather and rough seas, this ship's hull cracked under force of large waves, resulting in the leakage of approximately 20,000 tons of thick oil into the sea. So this steady leak from cracks and vents led to an estimated daily spillage of 100 tons. Oil leak from corroded pipe can occur without early detection and become one of the source of oil spills. For instance, in 2010, a rusty Enbridge pipeline rupture led to a significant oil spill, releasing about 843,000 gallons, approximately 3,180,000 liters of raw petroleum into Michigan's Kalamazoo River. This incident underscored the risk posed by corroded pipeline with undressed floors. Similarly, in 2000s, Petrobras caused a major environmental disaster in Brazil where a corroded pipeline ruptured, contaminating the Iguachu River with approximately 343,000 gallons, equivalent to around 1.3 million liters of crude oil due to inadequate maintenance. Oil spills can also originate from land-based sources, including industrial operation and urban waste. These spills often contaminate oceans through rainwater or river systems. For example, in 2007, Gowanus Canal in Brooklyn, New York experienced a spill of 363 million gallons of oil and waste. Similarly, in May 2015, a ruptured pipeline near Santa Barbara, California, discharged around 168,000 gallons of crude oil into the environment, polluting coastal water and harming marine life. So these incidents highlight the ongoing challenges in managing land-based sources of marine oil pollution.
There are several methods in solving the oil spill. The first one is the mechanical containment and recovery. They use foam to control and contain the oil, stopping it from spreading, and act as the first line of defense. Then, skimmer cam in various design can remove the oil layer from the surface of the water. For the chemical methods, dispersant can spray over the oil to disperse the oil into water column and remove oil from the surface. Solidifier can turn oil into solid, which make it easier to collect and remove from the water. For the bioremediation, it is the current most popular and strong method in solving the oil spill. It can be categorized into biostimulation and bioaugmentation. Biostimulation stimulates the growth of indigenous microorganisms and feed them with nutrients. Bioaugmentation addition of the natural or manufactured culture of microbe into the contamination site. Next is the in-situ burning. It is a very old method manage oil spill by igniting the oil on the water surface. Fire burn the oil, convert it into water vapor, carbon dioxide, and small amount of particulate matter and other gases. The last method is using solvents. It is the materials used to remove oil from water by absorption or adsorption. It can be made from natural materials or synthetic materials. It soaks up oil for easy collection and removal, making them useful for small spills or as the final cleanup step. The saturated solvents are then collected and properly disposed of or processed for oil recovery.
Moving on, in the bioremediation of oil spills, oil degrading microorganisms are used to break down the hydrocarbons within the oil, converting it into less harmful substances. Here, we have identified several microorganisms capable of degrading hydrocarbon. However, the most prominent one is Alcanivorax borkumensis due to the fact that it is well studied, widely used in bioremediation, and can metabolize alkane in crude oil. Hence, we have chosen this bacteria as our main oil-degrading microorganisms. Alcanivorax borkumensis was discovered in the North Sea near the Isle of Borkum, where it became prominent after the Exxon Valdez oil spill in 1989. It was isolated from seawater and sediments near the oil spill using enriched media with Mihagol S. After whole genome sequencing, its metabolic and adaptive features are revealed, which is it has adapted for oligotrophic lifestyle, it has high affinity for hydrocarbon substrates, it forms biofilm at oil-water interfaces, and it has systems for nutrient scavenging and specific stress responses. Alcanivorax borkumensis oil degradation involves two main pathways, which is the monoterminal alkane oxidation pathway and the biterminal alkane oxidation pathway. In the monoterminal alkane oxidation pathway, the alkane is converted into primary alcohol through the action of alkane monooxygenase. This is called as the primary oxidation. Next, the primary alcohol is converted into fatty acid through sequential action of alcohol dehydrogenase and aldehyde dehydrogenase. This is called as the secondary oxidation. The fatty acid will then enter beta oxidation for production of energy, or it will enter as the precursor in the biterminal oxidation pathway. In the biterminal alkane oxidation pathway, the fatty acid from the monoterminal oxidation will be converted into dicarboxylic acid through sequential action of omega fatty acid monooxygenase, alcohol dehydrogenase, and aldehyde dehydrogenase. The dicarboxylic acid will then enter beta oxidation for production of energy. Moving on, biosurfactant is a crucial component in alkane metabolism of Alcanivorax. First, it reduces the surface tension between water and the hydrophobic alkane molecule, enhancing the alkane uptake by the bacteria. Second, it emulsifies and solubilizes the oil droplet, making them more bioavailable to the bacteria. And lastly, it helps in the biofilm formation, which creates a protected microenvironment that supports the bacteria growth. Biosurfactant is often more preferable as compared to chemical counterparts because it is biodegradable, non-toxic, renewable, and it is sustainable.
In this section, I will discuss the development of our floater design, including the progression from initial draft to the final version. Our initial concept was to create a floater inspired by conventional blooms used to trap oil. The floater would incorporate the unique mechanism of the oil degrading bacteria, also known as Alcanivorax borkumensis. Unlike traditional blooms that only trap and control the spread of oil, our improved floaters also degrade oil through the immobilized bacteria within the device. Our first design featured a cylindrical floater with a hollow structure at one end, allowing oil and water to flow through the center. This initial idea focused on trapping the oil and controlling its spread. During the second stage of discussion, we revised the internal design to better suit the suggested mechanism from our team members. The initial concept involved bacteria coated with wax, while the second design leveraged the differences in density between oil, water, and bacteria. The revised design incorporated detailed sketches based on the mechanism proposed by our team. These sketches were then presented to our supervisor, Dr. Fauzi Mahmood, who provided invaluable feedback. The final design, as seen in the latest draft, reflects these improvements and enhancements.
Now, let's take a look on the next design. After we have conducted a meeting with our supervisor, which is Dr. Fauzi, Dr. Fauzi has provided some suggestions that we can look into for the design. From the last design, we have encountered some problems. Firstly, on the design, it may not be efficient to make it hollow with only one point of entry. This is due to the waves coming from the sea that may flip the product and may cause inefficiency for the sample to enter our product. Next, the problem is the cost of the product. We have found that the earlier design contains too much unnecessary materials like sensors and battery. So we have taken the suggestions from our supervisor on the design, in which is to make the shape of the product into a porous sphere or ball. This design is far more effective because now the point of entry has increased for the sample. And even if there are strong waves coming from the sea, the product will still be functional. So on the left figure is the raw sketch of the design, while on the right is the properly sketched design. This is our final product design, and we have prepared this using the SketchUp software. We can see the overview of the design and the close-up view where we can see the pores or the point of entry. We have chosen the orange color because it stands up so that it can easily be noticed. Now, let's take a look at the interior design of our product. As you can see, there are multiple layers of absorbent pads along with the immobilized bacteria inside the nanofibers. For the list of materials, firstly we have the absorbent pad. This pad has a special absorbent characteristics where it will only absorb oil and pass through the water. After that, we have nanofibers containing immobilized Alcanivorax borkumensis bacteria. This is where the biochemical reaction happen to degrade the oil contamination. Next, we have the airbag. The airbag function is to keep our product afloat when we release it on water surface. And lastly, on the outer side, we have attached a reflector tape where it serves as an indicator so that ships or fishermen can notice it from afar, thus avoid coming near with the product.
From the surface of the floaters, number of perforated pores can be seen. The function of these perforated pores is to assist in the movement of oil and water into the floaters. When the oil and water flows into the floaters, only water will be allowed to flow out, while oil will be trapped inside by the help of adsorbent pads. The oil will then accumulate and will be degraded by the help of specialized oil-degrading bacteria known as Alcanivorax borkumensis present in the nanofibers compartment. This innovative design ensures efficient and effective oil spill cleanup.
The Gantt chart outlines the comprehensive project timeline, highlighting key phases from initial brainstorming to final proposal preparations. Each stage is meticulously planned to ensure a structured approach, beginning with conceptual brainstorming and idea selections, followed by task delegations and prototype development. The process continues with detailed refinements and enhancements of both design and mechanisms, coupled with thorough financial forecasting. The final stage focuses on finalizing the mechanisms and preparing a compelling video presentations and proposal, ensuring all aspects are meticulously addressed for successful project executions.
Our budget comprises essential materials and supply sourced from reliable source, ensuring high quality throughout our production process. So each item has been carefully selected to meet our strengthened standard, and our budget prioritizes acquiring the Alcanivorax borkumensis, a premium bacterial strain for oil spill treatment. This strain have a lifespan of 10 years, and the final cost of our product is 3,869 ringgit and 79 cents.